Venus exploration makes a comeback.
Launches.
Shame on Boeing.
And we talk about Artemis III. And will it sink or save the return to the moon? All coming up on the next Orbital Edge. Welcome to Orbital Edge News, episode 3.2. I'm your host, Chad.
I'm your co-host, Kevin.
And joining us in orbit is Julia and Skylar.
Hello.
Hi.
Julia, we have some high-profile launches. Why don't you take us away on those?
I would love to. The United Launch Services Vulcan was launched at 4:22 a.m. EST on February 12th from Space Launch Complex 41 at the Cape Canaveral Space Force Station. Specifically, this launch saw the liftoff of a Vulcan Centaur VC-4S rocket, which has 4 solid rocket boosters and a 5.4-meter payload fairing. This Vulcan mission launched a multi-manifest national security payload to a geosynchronous orbit, which is just a fancy way of saying a U.S. Space Force satellite.
Approaching 1.5 miles an altitude.
You are hearing Daniel Brunson providing launch vehicle ascent data.
And pressure.
So, yeah, wow, look at that. That was that solid booster that had apparently busted a seal. So it's sprayed spokes. This was the same incident that happened in the last Vulcan launch. So something's going on in where they're actually producing these solid rocket boosters at the factory. I think they're using the complete same processes, and it doesn't seem like they've learned their lesson from the last incident.
Yeah. If has this same issue only happened twice so far?
Twice, yeah.
Yeah. I always go by once is an accident, twice a coincidence, 3 times a pattern. I would say maybe give them one more shot, but at that third point, definitely they should go in and be like, are we having a structural issue?
Yeah. All right, next up, Julia, looks like Ariane 6 went up.
4, 3, 2, 1, top. Allumage USR et décollage.
Oh, that one started.
Oh, yeah.
It was punching the pen. The announcers usually say, rumble in the jungle when they launch the Ariane. That's awesome.
Also on February 12th, at 4:45 p.m. UTC, Ariane Space launched 32 LEO satellites from Europe's spaceport in French Guiana. The Ariane 6, the vehicle that delivered the satellites, is a heavy launch lift vehicle designed by the ESA and CNES. The Amazon LEO satellites are part of the project formerly known as Project Kuiper, designed to create a large satellite internet constellation, which was established in 2019.
And next up is a Falcon 9 launch, and this is going to be the Crew 12 mission.
5, 4, 3, 2, 1, ignition, and liftoff. Go Falcon, go Dragon, and Godspeed Crew 12.
And liftoff.
A little bit
Freedom flies bound for the International Space Station.
This launch occurred at 5:15 a.m. on February 13th, and this is going to be the NASA SpaceX Crew 12 mission, which launched from the Space Launch Complex 40 at the Cape Canaveral Space Force Station. This is a science-based mission aboard the ISS where crew members will explore pneumonia-causing bacteria, for fluid generation, and different effects on blood flow in outer space, all to prepare for future long-term crewed space missions. And we have a bonus launch for everybody. We kind of forgot to put this in the show notes before the beginning of the show. So this is a Proton launch from Russia. It's been like over a year since a Proton has launched. And we're going to roll the footage here. Super cool.
No,
They almost look like symmetrical plumes as well.
Yeah, it looks very different from like a NASA launch.
Yeah, that the snow and everything. It just, yeah. Day and night difference. This launch occurred on February 11th. And again, this is the Proton rocket launching the Electro L number 5 weather satellite from the Baikonur Cosmodrome in Kazakhstan. And it was actually the final launch of the rocket with the Block DM upper stage. So it doesn't mean it's the end of the Proton, just the launch of that second stage. So it's really cool to see that rocket go up again, because it's been a long time. And I do love their new, the way they're doing their launch footage there. They're showing the graphic of the engines and everything. So they are taking a page out of SpaceX, which I do like to see. So with the launches in the books, we're going to move on to space news. And Skylar, you got a story about Boeing and NASA's report about them.
Yes, I do. So NASA leadership is calling for a major reset, and this time the criticism is coming from inside the house. NASA Administrator Jarek Isaacman was pushing for what he calls a new culture of ownership and accountability and transparency, after one of the agency's most uncomfortable near misses in recent years. So on February 19th, Isaacman openly criticized Boeing and NASA leadership over the troubled crew flight of the Starliner spacecraft. A mission ended up leaving 2 astronauts stranded aboard the International Space Station for more than 9 months. During his address, Isaacman revealed the results of the major investigative report ordered in early 2025 and completed later that year. And findings didn't just point to hardware issues, it pointed to something deeper. According to the report, it wasn't simply an engineering problem, it was an organizational problem. Boeing investigators say that they failed to deliver a spacecraft that met NASA's safety certification standards, but NASA didn't escape blame either. The agency's oversights of Starliner development was described as insufficient, with investigators saying that NASA wasn't hands-on enough to fully understand the challenges that Boeing was facing when they became mission-threatening problems. In a letter sent to NASA employees, Isaacman added that earlier investigations after Starliner's uncrewed missions failed to dig deep enough into the root causes of major anomalies, meaning warning signs may have been missed long before astronauts ever flew. And now NASA says it wants to make sure this doesn't happen again. Because as commercial spaceflights expands, the stakes and expectations are only getting higher.
Well, very interesting on that it's an organizational problem. But it's so weird that on Artemis, though, Boeing's working on the upper stage there, and there seems to be a day-night difference on that. Like, they can make that work, the ICPS, which stands for Interim Cryogenic Propulsion Stage. But here with Starliner, it's like, what the heck is going on there?
It's weird because with a lot of the stuff that's come out about Boeing as a company when it just comes to their aircrafts, where they've had a lot of issues with quality control, and I almost wonder if they're just somehow letting their own stuff slip through, because with the Artemis stuff, that is stuff that has to be checked over by NASA, because we want to take these to the moon. So there's probably a much stricter quality control there, is what I'm imagining at least.
Yeah, just an isolated incident, to make a short story short. So
yeah.
All right. Well, we have some awesome Venus missions coming up. Tell us about that.
So the 2 upcoming Venus missions we've got are Da Vinci in 2029 and Veritas no earlier than 2030.
I love the names of those.
Yeah. Da Vinci, we all know him. Both of these are acronyms. Da Vinci stands for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging. Their main goal is to study the chemical composition of Venus's atmosphere. It will feature a descent sphere that will actually go into the planet's atmosphere to be able to pick up the elements and everything in the atmosphere, so we can get a full, solid understanding of what chemicals and elements make up however much percentage of the gases in the atmosphere. They also want us. They also are expecting this to give us the first ever high-res photos of tesserae, which are Venus's equivalents to the tectonic plates here on Earth.
Sweet.
The principal investigator for this specific mission is James Garvin of the Goddard Space Flight Center in Maryland. And Veritas, or if anyone who knows Latin, that means the truth. Veritas stands for Venus Emissivity, Radioscience, INSAR, Topography, and Spectroscopy. Their main mission is to study the planet's surface. It will remain in orbit, unlike Da Vinci, which, like I said, will partially descend. It also will map out infrared emissions of the landscape to map the rock type, which we don't know what type of rock the surface of Venus is made up of. But also, I guess one of the main goals is to try to determine if volcanoes on the surface are releasing water vapor. See if there's water on Venus, which is cool. And the principal investigator for this specific program is Suzanne, I'm going to butcher this last name, Suzanne Smrekar of NASA's Jet Propulsion Laboratory in Southern California.
That is a lot of science.
Yep.
I'm impressed. It's like covering all bases on
No.
Venus exploration, all the way from the atmosphere down to the plates. That is insane.
It's crazy, especially because I remember learning like very early on in the space program, we did try to get information on Venus, but the atmosphere was so corrosive. It was like, well, we are sending these probes to send as much data as they can before they actually disintegrate.
All right, we're going to take a quick break, and when we come back, Artemis III, what's up with that? Stay tuned. Don't go away. All right, welcome back. Let's dig into this Artemis III situation. Big news. Artemis III was changed. We are not landing on the moon with Artemis III. Well, Skylar, you want to kind of start us on what's been going on, and then what is your opinions on this?
So, Jared Isaacman talked a little bit about what the issues were. There's a lot of issues with time in between the missions, and to kind of go back in time a little bit, compare it to the Apollo missions, because that's really the only thing we can compare it to. Apollo had 17 successful missions, with the only failure technically being Apollo 1. And all of this took the span of like 6 years. So I feel like with Artemis kind of taking such large gaps between missions 1 and 2, a little over 3 years each, whereas sometimes there'd be 2 missions within 1 year, 3 missions within 1 year with Apollo. I feel like a big issue, which was addressed by Jared Isaacman, that they kind of lose their edge a little bit. They kind of get rusty after such a long time, which kind of leads into a lot of the same issues. They talked about hydrogen leaks in Artemis 1 versus Artemis 2. So it kind of seems like they're running into the same roadblock, which could, I feel, easily be avoided, which from the press conference they had, it kind of looks like they're going towards that route. They're adding more missions to it. So as you said, it's not going to be Apollo 3. Artemis 3 is going to be Artemis 4, potentially 5. And yeah, the only other thing I could see about that is the potential that public might lose engagement a little bit. Kind of seems like we're expecting to be disappointed. We're expecting everything be pushed back another month or another year. So I feel like stuff like JWST and other missions like that would help keep the public engaged with NASA, kind of keep people excited for what's going on. Maybe NASA could do something with the Nancy Grace Roman telescope, kind of get people excited. Well, yeah, that's kind of my take on that.
Yeah, I wanted to add, basically, you want to compare Artemis 3 now, not to Apollo 11, but to Apollo 9, where they met up with the lunar module. So that's almost kind of the similar mission profile that's going to happen with Artemis 3. So it's really interesting to see that a lot more of these Artemis missions are going to go up in a less amount of time. I'm going to talk further about that and why that's important. But I do want to hear what Julia thinks about all of this.
So, my first thought was kind of like Sky was talking about the public engagement. Um, NASA's really trying to keep the public excited. And my first thought was that that probably has a lot to do with funding. We all have been keeping track of, the cuts proposed to NASA's budget. Thankfully, they did not get their budget cut basically in half. So that's great news. But yeah, I mean, I was shocked to see, such an increase in cadence with these missions, especially considering how long Artemis 1 and 2 have taken. I'm certainly excited by the possibility of more launches and more progress, but this is such a high stakes mission. The idea of establishing a permanent lunar base and eventually going to Mars. I really think it's important not to rush this mission. But again, I see how getting it done quickly is important, not just for, keeping everyone engaged and on their feet, like Sky was saying, but also potentially for funding. If we keep the public engaged, then, that encourages congressional support and more funding. And especially in the current political climate, funding isn't necessarily guaranteed long term. So I can see why they're trying to speed things up a little. I would be a little concerned, but I think that it could be a good thing.
Yeah, me too. Totally agree with you on that. All right, Kevin.
I'm gonna try to be a little quick. I'm a little bit of a negative Nancy. Basically, after just all the years of promises, I am losing some of the excitement. As you know, I'm alive because of the Apollo program, because my grandfather moved down here to work for Grumman and everything. I'm still excited to go back to the moon, but it just feels with all the delays, all the changes, it feels
Discouraging.
yeah. That's, I guess, the best way to put it. It's just the cycle of positive, negative news, all the changing. It just gets to be exhausting. And as Sky had mentioned earlier, we were doing so many more missions during the Apollo era. I actually did research into see the timeline of the Apollo missions and the timeline of Artemis. Artemis 1 launched in late November of 2022, so let's say about 3 years and 4 months ago. In 3 years and 4 months of the first Apollo launch, they went from Apollo 1 to 13.
Wow.
We are so far behind compared to that, despite the fact that we have more advanced technology. We have not even launched our second rocket in the time it took the Apollo program to launch 13. It's a little discouraging, but we're reinventing the science from scratch, and we are, so, it's understandable how hard it is to do this, but also they were able to do this over 50 years ago with less technology than what I'm holding in my hand. So I'm trying to be optimistic, but it does get a little sad sometimes. I feel like the thing that pushed us before was the space race, and as scary as it is to have the idea of being in a more modern space race, with some of the stuff we had discussed last time, I think it would probably be good for that kind of competition, because I feel like right now we're too relaxed. We are taking our time, and that's good, but I don't want us to lose our motivation. Because if we just feel like, oh, we can do it any time, then what's the rush?
Yeah, complacency is not exciting.
Yeah.
So I'm loving it. But again, we need to talk about Jared Isaacman and why he is doing this. He loved Apollo, and he wants that increased cadence. But there's some actual justifications here. You've got efficiency and cost. By launching these more often, it is going to bring down the launch cost of the Space Launch System. Also, it solves this problem with stale out, like everybody else was talking about. Maybe it's true that if we don't wait so long for each mission, we may have less hydrogen leaks, which is a constant problem. So, and then they, of course, need to figure out this helium issue as well. I want to add that, yes, agree with Jared and his justification, because Gemini was a program in the 60s that helped lay the foundation of the moon landing. And then there are Apollo's 4 to 10 missions. So if we were on that track, I think we may win this space race against China. So with that said, I'm going to get into our after show called After Dark about some of the misinformation that is spreading online and on social media about this whole issue with Space Launch System and Artemis, and also SpaceX is also in this whole fiasco, because there's issues going on with them. So just stick with us for After Dark as well to get some more information and opinions on that. Also, you wanted to...
just something that just crossed my mind as you were talking. I think you briefly mentioned the cost, and I was like, oh wait, yeah, they launched back in the day with basically just a bunch of hollow tubes, and now we have the most, like, some of the most advanced technology. It's probably expensive, so they're wanting to be like, we want to make sure this will work. So that is not thinking. I had not thought about that. That's my bad.
Yeah. There are more sensors now that they have to put on the, inside those rocket stages in the bulkheads. Way more sensors than they did in Apollo. So I can see the other side of the fence here on, why these issues can crop up on something so complex like the Space Launch System.
Yeah, thinking about the price tag associated with every rocket compared from then and now, I can definitely understand, yeah, we want to make sure that this thing actually does its job before we send it up. So that, I retract a little bit of my statement. I still believe what I said, but I think I had not thought about that. I am much more... No, I'm a little calmer now. Just a little bit.
Yeah, sometimes you just gotta take a step back and then just kind of look at all four corners, just to make sure you're covering all the bases. And then I wanted to just kind of round out my side of this about the people are fearing that the exploration upper stage, or the EUS, is going to be canceled. That's the bigger stage they're going to use for the Block 1B, like the larger SLS. For later launches. Thing is, that is a congressionally mandated program. So in order for that funding to stop, Congress has to stop it first. So people on the Twitter saying, oh, there goes EUS. Nope, not true. All right. Well, that's going to do it for the topic. So we're going to take another break, and when we come back, comments from the last show. Stay with us. Welcome back. Before I begin into the comments, if you enjoyed the show so far, don't forget to like and subscribe, and also share this show with anybody you know who loves spaceflight. All right, and our first comment comes from Jared Head on YouTube, and he is a high-profile space communicator, so it means a lot that he came onto our channel and checked us out. And here's what he has to say. What a fun show to come across. Love the roundtable and discussion on the topics. Can't wait for February show. Best of 2025. A tie for us with Firefly sticking the moon landing on the first try with their Blue Ghost lander, and New Glenn landing their stage 1 on the second launch. The worst in space of 2025? SpaceX Starship testing hiccups. They lost a lot of chances to get critical data about important portions of flight like Starship's reentry profile and tile performance. For 2026, his expectations in space is Nancy Grace Roman Telescope, bigger field than Hubble plus infrared, launch and commissioning can't come fast enough. Thanks a lot, Jared. It's an awesome comment, and I like how your suggestions for what you chose for 2025 and 2026 were pretty much on par with what I had and what Jacob had, Kevin had on the show. So that's going to do it for the comments for the last show. Before we end the show, we want to answer the orbital trivia, and the answer is liquid hydrogen and liquid oxygen. But I have a bonus question, and anybody can answer that in here. Which of the two fuels that I just mentioned is the larger ratio?
I feel like I should know this.
I'll give you a hint. Julia did a space pod on this. It was a launch and learn about a wet dress rehearsal.
Is it the hydrogen?
Yes. So the hydrogen is the larger fuel mixture. It's simply in a larger physical tank, and then the liquid oxygen is smaller. So that's your answer for the bonus question. All right, so that's going to do it for this month's show. Again, I've been your host, Chad.
I've been Kevin.
Julia.
And I'm Sky.
And we will see you next month. Bye.
Bye-bye.